Oops, and you guys probably need a light. Sorry. Is that better? Okay, guys. Bell ringer, we don't really need that. That was pretty simple from yesterday. Let's scooch down to the bottom. This formula is one you should recognize. We used it yesterday. We're going to assume that P is 1, R is 1, and T is 1. And they filled it in for you. In your calculator, find A. Yeah, capital A. How about that? Find A when N is 1, N is 10, N is 100, 1,000, 10,000. See what you come up with. Whoops. It says, what does A appear to be approaching? Usually things approach 0 or something like that, right? It's approaching a really weird number. This is a number that has showed up so often they've given it its own name. It's called E. Just like pi shows up all the time, so they gave it its own name. It's pi. This is E. Take your calculator and look on the left-hand side. You see the button that says ln for natural log? Yes. You see above it in blue it says e to the x. Everybody hit second natural log, and in your calculator screen it says e to the, and it's waiting on you to push something. Put 1 so we can find out the value of e. Ta-da! So second natural log, you're going to take that e to the first power to find out its value, and it's 2.7168. It's just a number that shows up so much they gave him his own name, is what happened. So when you see that e, it is not a variable, it is a replacement for a number. Just like pi is not a variable, it's a replacement for 3.1415, right? Okay. So let's put e right here. Alrighty, flip the page. The number e. I want to start out, let's see, let's scooch down the page. I want to start with number 3 actually is what I'd like to do. So suppose Karen deposits a bunch of money in a savings account that earns so much percent, compounded continuously. Ding, 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 ding. That's your little phrase. That means you have to use this formula. A equals PE to the RT. A lot of people call it the PERT formula because it looks like it spells PERT. Not all of those are variables. Remember, E is a number. She plans to withdraw the money in 6 years and to make a $2,500 down payment on a car. Does she have enough money? Let's find out. We don't know what she'll have in the end, but she started out with how much money in the account? $1,500 times E to the RT. What do I put for R? 0.0675. Don't forget it's a decimal. And for how long? 6 years. Type that in your calculator. Let's figure out what we get. Anybody get there yet? What'd you get? Okay. 2248.95, right? So the question says, will there be enough funds in Karen's account in 6 years to meet her goal? No, she doesn't have enough money. Wah, wah, wah. I know. She needs to get a better job, I guess. Sad, sad. Alrighty, let's scooch back up to number 1. Actually, no, go to number 4, sorry. Number 4, it says, given the original principal, the annual interest rate, the amount of time, the type of investment, or the type of compounded interest, find the amount. What I want you to be aware of is that these are asking for 2 different formulas. One of them is compounded semi-annually. That's yesterday's stuff. We said A equals P times 1 plus R over N to the NT. And one of these is compounded continuously. What do you do if it says compounded continuously? PERT. Good. So I'm not going to make you waste your time sticking that calculator. I know you guys know how to do that from yesterday, but that, just watch for your words is what I'm saying. Questions? Okay. You got that written down? Hang on, we're almost there. Okay. Number 1, demographics. In 1995, the population of Kalamazoo, Michigan was 79,089. This figure represented 0.4% of an annual decline, watch that word, from 1990. Let T be the number of years since 1995, that's also kind of a big deal. And write a function that models the population of Kalamazoo in 1995. So let's see here. We're going to use the same formula, but it's got different letters, and I don't want it to throw you off. Yesterday, do you remember seeing those letters? Yeah. It is the PERT formula. It's the exact same thing. They've just used a couple of different variables. Whoops, and this is a K, actually. Sorry. It's the same formula. If you look at it, everything still matches up. They've just used an N and an N sub 0.
Is that a K?
Yes, that's a K. And it's basically rate is what it is. So if you just memorize the PERT formula, it'll still get you there. So let's look at this. We have to come up with some sort of function here. So we have N equals, how many people are initially in Kalamazoo? Good, 79,089 times e to the k, or rate. What do I put for rate? I love that you got your decimal right, 0.004, but something else is wrong with that. What else did I underline up there in red? Decline. We are not increasing, we are going down in population. So what does that mean about that percent? Negative. And then T. T is time. It just says to write the function. It doesn't say to answer the question. It says write the function. Yep, got to read the question. Letter B, predict the population in 2010 and 2015. Just to save time, guys, we're just going to do 2010 right now. So we have N equals 79089 times e to the negative 0.004. What's T? 15. Why isn't it 2010? Good. It said let T be the number of years since 1995. It's been 15 years. So we put a 15 there and we type it all in. And then somebody tell me what you get. I heard it. What is it? 74,483. Was everybody able to get that in their calculator? And what's our label on that? Are we talking about cats or what? People. Alrighty. Can I move on? Is everybody okay? Number 2. Suppose a certain type of bacteria reproduces according to the model, and this is a model we've been messing with, but just know in your homework, some of those problems, it's going to give you a bizarre looking equation. The good news is they gave you the equation. You just have to read and insert numbers in place of letters. Anyway, this is the same equation we've been used to, where T is time in hours. They're asking you to interpret the equation now. Letter A, at what rate does this type of bacteria reproduce? Well, what's the rate? Look at your little rate up here. 27.1 what? %. What's the initial number of bacteria? 100, so there's your principle right there. Let's read letter C and think about it and make sure you know what it's asking. It says to find the number of bacteria at P at 5, P at 10, P at 24, and P at 72. Very good. Thanks, Ocean. That's perfect. These numbers that are changing are hours. This was P at T. They're saying take T and plug in 5. And then plug in 10 for T, and then 24, and then 72. I'm not going to waste our time typing all that in. I know you guys can type in a calculator. But I just want to make sure you understand that's what it means. In case you're worried you might forget, you might write the first equation. P at 5 equals 100 times e to the 0.271, and we're going to put a 5 in place of t. So P at 5 would equal whatever that answer is. And that's one of the 4 answers. Questions? All right, flip the page. It has been a while since you've seen logs, and if I remember right, when I taught Algebra 2, you guys go through those pretty quickly. So you probably need like a fast review. So we're going to write some stuff at the top of your page. Here we go. Log base b of m times n. Now let me just say, logarithms, guys, in case you're confused about what that even means, a logarithm is the inverse of an exponent. It's how you undo an exponent, just like subtraction undoes addition. Multiplication undoes division. Logs undo exponents. So if you have log base b of m times n, and these are somehow related to exponents, the rules kind of apply. If you're multiplying two things, then you can split these up and add them, so that I have log base b of m plus log base b of n. It's called expanding when you do that. And it's going to ask you on your homework today to expand the log, and you're going to have to break it apart. It might ask you to condense. That means shrink, make it smaller. So it might give you the right-hand side, and you have to come up with the left-hand side. Notice the bases match all the way across. So if I have log base b of m divided by n, it's going to be the same as log base b of m, what? Minus log base b of n. Good job. If you have log base b of m to the nth power, and this is the one kids always forget about, you can take the n and catapult it over the top, and it winds up in the front so that it looks like n times log base b of m. Those two things mean the same thing, and you are going to have to go back and forth on those today as well. One more little law to write down. If you have log base b of m, and it's equal to another logarithm that has the same base, then that means m equals n. You can cancel out the logs. For years I used to say drop the logs, and then some kids started snickering, and then the whole class started snickering, and I understood what I'd been saying all those years. So we're dropping logs today, guys. We are going to cancel the logs out so that you have m equals n. Does that make sense to everybody? Everybody all right? Okay. I know. Ocean would prefer me say dropping logs. I love that this is on video as well. Your parents will be thrilled. Okay, number 1. It says to write each equation in exponential form. Lots of teachers teach this different ways. I don't know what Miss Pepin taught you last year. I don't know what Miss Jackson taught you, but here's what I'm going to teach. I'm going to teach 2 different methods, and then you do whatever you want on the third one. Let me just show you. And this is a dumb story, and I know that. This is like totally elementary, but you'll probably remember it. So I'm going to pick up this base, and when I pick it up, the log fell off. And I'm going to throw it across this river. When I throw it across the river, it bumps into the 4, and he gets moved out of the way, and the 81 remains untouched. I know it's dumb, but a lot of kids remember it that way. And you know you're right, because, guys, 3 to the 4th power is 81, correct? Okay. There's another way, and this one I saw on Pinterest. A lot of kids like this last hour. So hang on, before you draw the picture, you might want to watch. Yep, ready? Just watch. Log, oh wait, sorry. I'm going to screw this, I already screwed it up. Hang on. I'm changing into an exponent, so I'm going to draw an E. Take the base, and it's going to be 8 to the 1/3 equals 2. And it makes an e for exponent. So 8 to the 1/3 equals 2. Which is also true. Some kids really like that one.
I like the one.
Yeah.
Totally up to you. It doesn't matter. So tell you what, you pick either method or your own and do number 3 by yourself. And guys, that's pretty easy to figure out when it's all numbers because you can double check it with your math and know if you're right. Just know that on your test on Monday, all of those might be variables, and so you're not going to be able to double check it. So make sure you know what you're doing. Does that make sense? Okay. All right, next one. We're now converting from exponents to logs. Again, I've got a couple different methods. Use whatever you want, but I'm going to talk about this out loud in case somebody needs it. If the base of the exponent is 3, then the base of my log is going to be 3. These two guys trade places. So 27 goes here, and the little guy, the exponent, he's all happy because he's big over here by himself. He gets to be a big guy. No, it's not really a story, but it's a dumb little thing that you might remember. Now here's the Pinterest way, and this is kind of interesting. Because you're changing to a log, you're going to draw a great big L. You want to watch it first, probably? Here we go. Log base L of 1/125 is -3. You see how it makes a big L? Log base 5 of 1/125 is -3. So log base 5 of 1/125 is -3. Okay, I don't care what method you want to use. You guys do number 6 by yourself. Oh my gosh. Did everybody get what I got? Everybody's okay? Okay, moving on. Am I going too fast? Are you happy we're reviewing?
Yes.
Good. Evaluate each expression. I'm going to skip around a little bit. I want us to start with number 9. Okay, they want you to evaluate. You're solving it basically. You're simplifying it. And we don't know how to do common logs at this point. We are not using common logs, so don't try to pull that out. And if you don't even know what I'm talking about, then great. All the better. Right, equals x. And now we're going to do exactly what we did on 1, 2, and 3. We're going to turn this into an exponential equation. So whatever method you're going to use, I'm going to pick up the base and toss it across the river, and it bumps the x out of the way. When I picked up the base, the log fell off. Pick up the base. When I picked it up, I bumped the log off. I threw it across the river, and it bumped into the x and bumped him out of the way. The e one, this one, start with the base, and you say 8 to the 1/3 equals 2. So for this one, it would be 8 to the x equals 4096. Now here's the thing, we still have to solve for x. Now some of you guys are pretty brainy and you're going, oh, x is 4 because 8 to the 4th is 4096. You're not always going to be able to whip it out that fast because sometimes it gets a little more complicated. Your goal, and write this down, is get the bases to match. If you can get the bases to match, then you're home free. Here's what I mean by that. Well, actually, you know what? Let's just wait and we'll talk about it a little bit more on number 10. Let's finish this one up. Because we know, and I realize you could just put x equals 4. 4096 is 8 to the 4th. Whoops, that's an x, my bad. Once you get these bases to match, then the exponents just equal each other. So 4 equals x.
Is that basically just using still using just your knowledge of OS4.
Yeah, but on number 10, it's not going to work. On number 10, it's not going to work. What they wanted you to do on this one, Tiffany, is they wanted you to change 8 to 2 to the third power. And then 4096 to 2 to the whatever that is. 12, thank you. All right, let's look at number 10. Everybody write equals x, and then change it to an exponential equation. Good. And you know by looking at it now, the problem with this is 4 to the something. I have no idea how to get that 32. You want your bases to match. What I do know is that I can replace 4 with 2 squared. So go ahead and do that. Replace your 4 with 2 squared. And 32 is 2 to the what? 2 to the 5th. I heard it. Your bases now match, so you can set your exponents equal to each other. On the left-hand side, I have a 5. On the right-hand side, what do you do when you have a power raised to another power? You multiply them, so that's 2x. So for this problem, 5 halves equals x. That one would be harder to get to. You have to get those bases to match. Everybody okay? I want to show you a couple special cases. Let's look at number, well, actually, you know what? Let's go to number 7. 7, we're going to work it out the long way, and then you're going to see the law. If we say equals x, turn it into an exponential equation. And we have 7 cubed equals 7 to the x. So that 3 equals x. When the base of the exponent and the base of the log match, then it's just whatever the exponent is. When the base of the exponent and the base of the log match, it's whatever the exponent is. You can work it the long way. We just did. But you don't have to. Huh? No, you don't have the base. You have the you're looking for the exponent, sweetheart. We have the bases. All right, let's scooch down. I don't want to do all of these, but I do want to approach 14. We're trying to solve the equation, and if you look at it, it looks just like the ones we've been doing, but they wrote the x for us. Turn that into an exponential equation. Yours should match mine. And now some of you are going, what do I do now? It is very likely you'll see this on a test. Maybe. I'm just saying, maybe. If you saw something like this on a test, I think what a lot of kids do is that they panic and they don't really know what to do with it, and you can't have a calculator. So they're really stuck. What's another way to write 0.25? 1/4, right? One-fourth is the same as 4 to the what? Aha! So -1 equals x. This is the same as 4 to the -1. You guys remember that? What? It'll be something you can pull together. It'll be something like this one, like it's 1/1000, which is 10 to the third, so it's -3. You know what I mean? Okay. Let's look at number 15. 15. You have logs, and there's only one on each side. The bases match. Keaton says we're dropping logs. Okay. So we drop the logs, and we have 2x minus 1 equals 16, and now it's just algebra 1. This is like 7th grade. Add 1 to both sides, and we get 17 halves. Questions? All right, let's look at 16. Turn 16 into an exponential equation. Huh. Now what?
One half.
Brilliant! Such smart kids. So this is really 10 to the 1/2. So 1/2 equals x. Inside over outside. That's right. Inside over outside.
What's that funny?
I don't know. It's just funny to me that you said it, I guess. I don't know. Alrighty, we're looking at 17. Oh, no, this is not hard. You guys can do this. Before you can drop the logs, and let me make this very clear, because every year I have kids screw this up. A lot of kids look at that and they're like, oh, great, I'll start canceling out the logs. You can't do that until you get 1 on each side. You've got 2 on the left-hand side. We need to condense it first. So, I see a subtraction sign. I'm going to keep the base the same, so it's log base 7. What do I do with the 56 and the x?
56.
Good, 56 divided by x, we're condensing. Equals log base 7 of 4. Do what? Yes. Yes. Because it's minus, the first one goes on top. So we have 56 over x equals 4. Multiply both sides by x. Divide and you get 14. Questions on 17? Is everybody okay? 18? 18? There are a couple like this on your assignment, so I want to make sure I mention it out loud. You're adding... Wait. First of all, why can't I just go cancel a bunch of logs? You've got 2 on the left, so we have to condense. We're adding, so what do we do with these guys? Multiply. So I'm going to have... Yeah, I'm going to go ahead and distribute, so I get x squared plus 4x, and it's log base 5 of that whole thing. Then you can cancel your logs. But now what? Factor if you can, and what happens if you can't factor? Quadratic equation, and you will have to do that at least once today. I know, right?
This one.
Wah, wah, wah. So sad. Carson, what'd you say?
This one factor.
This one factors. Hooray!
Negative 6 and 2.
He says negative 6 and positive 2, and I'm... How about positive 6, negative 2?
No, that's... Well, the final answer is...
Oh, the final answer. I see what you're saying. I understand. Sorry. Now, here's the thing. We have a couple of answers, and we haven't been checking any of these answers so far. There's a problem with one of these at least. The base and this guy right here, neither one of them can be negative. They have to be positive. So this says log base 5 of x, and this says x is negative 6. If you type that in your calculator, you come up with an error because it's undefined. So this is not a possible answer. Check the rest. If I put 2 plus 4, that's a positive 6. That's good. A 2 there, that's positive. I'm good. 2 is my only answer that works. So on the side of your paper, make yourself one last note. For log base b of m, b and m must be positive. On the back of that sheet is just the thing I printed off of Pinterest, just to kind of remind you.